In this video, we're going to look at the function operation called composition. The symbol is an open circle. In our last video, we looked at addition, subtraction, multiplication, and division, and we saw that multiplication was either the two letters next to each other, or with parentheses around each other, or with a small closed dot. Composition has a different symbol, which is an open circle. So be careful about the difference there. If I'm given a function, for instance, f of x equals 2x plus 5, and g of x equals, let's not use 2 again here. Let's just use 3x squared minus 2x plus 7. So I'm just making up these two functions. Those will be given. Those will be known. And I wanted to find the composition of them. Composition of functions is a function of a function. So if I have f composed with g of x, f composed with g of x. And remember the of x here, that piece is just saying what our independent variable is. So f composed with g is the name of this new function. And we're going to see that it is a function of a function. G is called the inside function, and f is the outside function. So we're going to take f of g of x. And notice that these are in the same order, f, g, x. So g is still the inside function, f is still the outside function. But we already know what g of x is. We know that g of x is 3x squared minus 2x plus 7. So f of g of x is f of what g of x is. And I'm going to go ahead and write this in red so we can see what happens here. And remember what we learned in an earlier lesson. This, the f, means where we're plugging in for x, where we are replacing x. And this, that's in the parentheses, well, in the parentheses is what we're putting in place of x. So in the f function, wherever we had an x, we're going to put all of this that's in the parentheses. So I have 2, my 2 here, times what's replacing the x, 3x squared minus 2x plus 7, plus 5. And then I can distribute the 2. And then combine like terms. So we have a new function here. F composed with g of x is equal to 6x squared minus 4x plus 19. Let's try it the other way around. Let's find g of f of x. In this case, g is the outside function, and f of x is the inside function. So in this case, we were taking whatever f of x is, (2x plus 5), and we are plugging it into the g function. So that means now we're looking at the g function, and wherever I had an x in the g function, I'm going to put what is in my parentheses here, 2x plus 5. So I'm going to have 3 times the 2x plus 5 all squared minus 2 times the 2x plus 5 plus 5. So if I'm looking at, I'm going to just jot down the g of x function here so we can see what it was, so it's all on the same page here. So if I'm looking at this function, I have the 3 times what replaces the x, 2x plus 5, all squared, minus 2, and then the 2x plus 5 is replacing the x, plus 7. And I see I made a mistake here. I'm glad I went back and checked that. Should have had a 7 there from the g function. All right, we know by function operations that we need to square the 2x plus 5 first. So I'm going to go out here in the margin, and I'm going to remember that 2x plus 5 all squared is the same thing as 2x plus 5 times 2x plus 5. So I have to FOIL that out. 2x times 2x is 4x squared, plus 10x plus 10x plus 25 is 4x squared plus 20x plus 25. So all of this is just this piece here, 2x squared plus 5 squared. So I have 3, just come straight down. And I can go ahead and distribute the 2 here. And now I can distribute the 3. And then adding the negative 10 and the 7. And then combining again. All right. Now, if I did that a little bit quickly for you, what I would recommend is that you pause your video and try to work out the math yourself there, and then catch up and double check that it gives you the same answer. So I have found a new function. G composed with f of x is equal to 12x squared plus 5x, 56x plus 72. And notice that that is different than f composed with g of x. Those give me 2 different functions. Composition is not commutative. That means order matters. The order that you do the composition matters. Let's look at a real-life example of where composition of functions would be useful. Let's say that there was an oil spill off of a ship in the ocean, and that it is known that the radius of that oil slick, of that circle, so we have the oil slick here, and it's getting bigger and bigger and bigger as time goes by. And this is my radius here to the edge of the circle here. So let's say that we know that the radius is growing at a rate of, that we know that after each day, the radius will be 2 times t, where r is in miles and t is in days. So after 1 day, the radius of the circle is 2 miles. After 2 days, the radius of the circle is 4 miles. After 3 days, the radius of the circle is 6 miles, etc. And we also know that the area of the entire oil slick is given by pi r squared. That's just the formula for the area of a circle. And what I want to do is find the area of the oil slick at t days. In other words, I want to find a formula for the area in terms of t, time. Well, we know a formula for area in terms of radius, and we know a formula for radius in terms of time. So A of t is going to be A composed with R of t. And as we saw in our example before, that's A of R of t. R of t is 2t. So we can replace R of t with what it's equal to, 2t, the radius at time t. And then now we can replace the r in the radius function, the area function with 2t. The area function is a pi r squared. So we have pi, and remember pi is an irrational number. It's approximately equal to 3.14. So we're just using that as a number. We don't have to do anything different with that. And then my r here is squared. So we have 2t all squared. So I'm going to have pi times 2 squared, which is 4, times r squared, and then getting that back in order, we have 4 pi r squared. So this is an example of composition of functions in the real world. If we know one function and then another function, and we want to get them together into one function where we can just use a single formula, we can use composition to do that. In our next video, we're going to look at the concept of the difference quotient, and we're going to see that that's a formula that uses subtraction and division of functions, and it's a formula that's used in calculus.